Well, the first step is to do some CAD modelling. Then we go to the 3D printer to make several thousand polyacetal nozzles.
How are these designs tested during development?
We've got an optical measuring machine that's accurate to 2 microns. We've got a laser droplet analyzer, and that allows us to know exactly what the droplet spectrum is. And finally, we've got a patinator, and that's essentially a section of spray boom where we check the evenness of spray of a series of nozzles. And we're looking for a patination, a coefficient of variation of less than 7%. And that means that between even as low as 35 centimetres right up to 75 centimetres, we're going to get good even distribution. That gave us something that was robust enough to hand to Syngenta for a season's worth of spraying. And that gave us some really good quality information at a very early stage in the nozzle development. The final design is more compact and more elegant. It's got 3 components: a pre-orifice that meters the flow, a tip that makes the pattern, and the body that produces the incline. Because the nozzle is specific to the 3D90, every 3D90 is going to get delivered with its own cap.